Good evening, children. Good evening, children.
Good evening, ma'am.
Good evening. Yeah. Take down this question. Question number 4. If the centroid of a triangle ABC with A, B, and C is the origin, if the centroid is the origin, and we know that the origin is given by the coordinate 0, 0. Origin is the point where the x-axis and y-axis intersect. It's given by the coordinate 0, 0. So if the centroid is at the origin, that is the centroid is given by the letter G and the coordinates of G 0, 0. If the centroid of triangle ABC with ABC given to you is the origin, the centroid is the origin, find the value of A plus B plus C. Find the value of A plus B plus C. You work, children. So because you can understand that, you please work it and then I'll tell you what it is. Start working. Write down the question first, draw the figure. Figure is to incorporate the information, to see the information visually. All right. So the triangle A given by A comma B, B given by B comma C, and C given by C comma A. The vertices of the coordinates of the vertices A, B, and C. The centroid is at 0, 0, the origin. All right. And we know that the centroid lies on all the medians. The centroid lies on all the medians. Okay, it lies on the median from A. It lies on the median from B. It also lies on the median from C. It lies on all the three medians. So we have just considered one median here from, not one median. We have here considered the median from A, AD, which is the median from A. So the centroid will lie on it, will lie on the median AD. So G given by 0, 0. Now we have to find the value of A plus B plus C. All right. Okay. So now see, we have to find the value of A plus B plus C using the information given. So we are given the centroid. We are given that the centroid lies at 0, 0. So let's make use of that information. To make use of the centroid, you need to find the coordinates of D. To make use of the centroid, you need to find the coordinates of D. So what is D? It's the midpoint of BC because AD is the median. D is the midpoint of BC. So how do you find the coordinates of D? Since it's a midpoint of BC, B plus C. Add the x coordinates, divide by 2, comma, add the y coordinates, divide by 2. B plus C by 2 is the x coordinate of D. C plus A by 2 is the y coordinate of D. So we found the coordinates of D using the midpoint formula. Now, what is the x coordinate of the centroid? The x coordinate of the centroid. You can also take the y coordinate of the centroid, anything. The x coordinate of the centroid is 0. And how do you find the x coordinate? Mx2 plus nx1 by m plus n is equal. See, I've taken a different figure here. I've taken only the median AD, and I've written the coordinates of A comma B, the coordinates of D, the median AD. This is the median AD. Coordinates of D here, B plus C by 2, comma, A plus C by 2. Okay, and median lies here, G 0, comma 0. Dividing the median, sorry, the centroid lies here, G 0, comma 0. Dividing the median and the ratio 2:1. Dividing the median and the ratio 2:1. So you can see it here. This is the median AD. Coordinates of A and D, which we just found. This is the centroid, which lies on the median AD. Coordinate 0, comma 0. Ratio 2:1. From the vertex to the centroid, 2 points. 2 parts, and from the centroid to the midpoint, 1 part. From the vertex to the centroid, 2 parts. From the centroid to the midpoint, 1 part. So here AG is 2 parts, GD is 1 part. Now use a section formula. How do you find the x coordinate of G? Use section formula. Mx2. So 2 into B plus C by 2. Okay, so 2 into B plus C by 2 plus 1 into A, mx2 plus nx1 by 2 plus 1, 3. By 2 plus 1, 3. Work this. 2 and 2 gets cancelled. So you get B plus C here, plus A. 1 into A is A. On cross multiplying, 0 into 3 is 0. So the value of A plus B plus C is 0. The value of A plus B plus C is 0. Yes, children, please complete it if you have not. Done, children? Is it over?
Yes, ma'am.
Yeah. Thank you, Tarun. So this we've already done. 5th one I've already worked for you. So I'm not doing the 5th one. All right. Now this also we have done. Yeah, we've done this. Yeah. Let's do the 7th one. 7th one. Yeah, I think you can do that by yourself. Work the 7th one. Seven and 8, you can help yourself. You can ask me if you have any questions. Abscissa of B meaning the x-coordinate. Abscissa is the x-coordinate, that is 10. Y-coordinate, we do not know. That's what we have to find. Find the ordinate of B. Find the y-coordinate. So we'll take it as y, 10, comma y. And then the distance formula. Finish the 7th one, children. Yeah, I hope the 7th one is over. Have you written the 8th question, children? Yes, ma'am. Very good. You can see the answer here. Yeah. So since it's given that P is equidistant from Q and R, P is equidistant from Q and R. P, Q, R. And the x coordinate of P is twice its y coordinate. X coordinate of P is twice the Y coordinate. So if the Y coordinate is Y, the X coordinate is twice that, twice Y. The X coordinate is twice the Y coordinate. Y coordinate is Y. So the X coordinate will be 2Y. Q and R given to you. 2 minus 5 minus 3, 6. 2 minus 5 minus 3, 6. So PQ is equal to PR because P is equidistant from Q and R. So PQ is equal to PR. You should work that condition, or PQ square is equal to PR square. And I have not expanded here. I've transposed. I've taken this to the left hand side and I've got this to the right hand side. So they look like a difference of 2 squares now. A difference of 2 squares. You can also expand. You can also expand using the formula a plus b the whole square, a minus b the whole square. That also will give you the same result. I have transposed this y here and this 2y here. So we have a difference of 2 squares, a square minus b square on both the sides. So you can see here a plus b, a minus b. A square minus b square is a plus b into a minus b. Yeah, then you'll have to multiply minus 5 with all these, both these terms. Here minus 11 with both these terms. And solving, we get y is equal to 8. So the coordinates of P, 16, 8, 2y, y, 16, 8. Write down question number 9. Don't write all this. Just write the question. Don't write all this. And draw both the diagrams. Draw both the diagrams. Is it over, children? Have you written the 9th question and the figures?
Yes, ma'am.
Yeah, thank you. So this is how we continue. I think this one also we have done earlier, dividing by 29 throughout, I remember. Oh, we have worked this earlier, children. Dividing by 29 throughout, I remember. Oh, we have done this some earlier. Please ignore this. Yeah, we can do this one. Sorry, children. Please work this. Similar question. Please work the 10th one. You can see the complete answer on this page. And we have done a similar one. So you can help yourself. Class use the emoji, raise your hand. Rajeshwari, Rajeshwari, Tarun Murali, Kanishka, Shreyas, Nandini, Murali Krishna, Hitesh, Netra, Priyanka. Are you there, Priyanka? No response. Last class also the same thing happened. Finish writing this one, children. Done working this, children? Yes, I want a few responses. I know all of you are not going to respond. Tell
Yes,
me.
ma'am.
Very good, Tarun. Thank you. All right, yeah. Okay, so here we are given two vertices, two diagonally opposite vertices of a square, and we have to find the coordinates of the remaining two vertices. We are given the coordinates of two diagonally opposite vertices. See here, we know the coordinates of P and R. P and R are diagonally opposite to each other. The vertex P and the vertex R are diagonally opposite to one another. So we are given the coordinates of P and R. With this information, just given this, we have to find the coordinates of the remaining two vertices Q and S. of the square PQRS. Okay, so as we have understood earlier, assume the coordinates of any one of the unknown vertices, any one, either Q or S. Either Q or S. Okay, so we have to find the coordinates of Q and S. So let us assume the coordinates of Q to be X comma Y. That's enough. You don't have to assume for S. So just assume for Q or for S, any one. So let Q be given by the address X comma Y. So you can see here, children, P minus 1 comma 2, R 3 comma 2, PQ here. See, Q can come here or here. So if this is, see, if this is Q, S will be here. If Q is here, then S is here. If Q is here, then S is here. All right. Okay. So we have taken the address of Q to be X comma Y. So if Q is here, this will be the position of S. Or if Q is here, then this will be the position of S. Okay. So two conditions we have to use here. That in a square, all sides are equal. And also in a square, you can just connect this diagonal. And this one is a right triangle. Use Pythagoras theorem here. See, don't see this part at all. Don't see this part at all, okay? Don't see this part. Now, first work PQ is equal to QR. PQ is equal to QR. Work that one first. And then use Pythagoras theorem. PR square is equal to PQ square plus QR square. Use any one triangle. Take out, forget the other one. Now, when you join the diagonal PR, there are two triangles. Just look at this, forget this, or you take this and forget this. Take any one of these two triangles. So what I've done, I'm just looking at this. I'm not considering this. So first condition, PQ is equal to QR. The next condition is PR square is equal to PQ square plus QR square, Pythagoras theorem. That's all. You just have to remember this. So what is the procedure? When you know the address of two vertices, how do you find the address of the remaining two vertices? So remaining two, but you just take one of the two and let the address be X comma Y. So put all this information in a diagram and then use the properties of a square. In a square, all sides are equal. So PQ is equal to QR. And then there's a right triangle. So Pythagoras theorem. So with these two, conditions, you will be able to find the coordinates of Q and S. All right. So PQ square is equal to QR square. So you know how to do this. You can also transpose this here and bring this here and do it, children. That also will give you the same result. Okay, so this here I've just expanded a plus b the whole square, a minus b the whole square, expanded, simplified, and 8x is equal to 8, x is equal to 1. So we get directly, so not always will you get the value of x like this directly. So here we get x straight away, x is equal to 1. Now use Pythagoras theorem. So this is the condition. And how do you write PR, PQ, and QR? Distance formula. Distance formula. PR square. So x2 minus x1 the whole square plus y2 minus y1 the whole square. So that's what you see here in this step. And then this one works to 16 is equal to, I've expanded all this. And on simplifying, we know the value of x, children. So wherever there is x, you can use 1. I have simplified and then use the value of 1. Value of x as 1. See in this step, so where there's x, use 1. Where there's x, use 1. Because the value of x is 1. So that way you'll be able to find the value or values of y. So when you work this equation, you get 2y square minus 8y. And always, whenever there's something common, bring out the common factor. So 2y is common into y minus 4 is equal to 0. So that means either 2y is 0 or y minus 4 is 0. 2y is 0 or y minus 4 is 0. So which means y is equal to 0 or y is equal to 4. So y takes two values, 0 or 4. Now find the corresponding values of x. Find the corresponding values of x. But x is only one value here. X is equal to 1. So for this value of x, y has two values. When x is 1, y has two values. Y is equal to 0 or y is equal to 4. So we have two addresses now, 1, 0 and 1, 4. 1, 0. See, when x is 1, y is 0. And when again x is 1, y is 4. So the addresses are 1, 0, 1, 4. So if this is Q, this is S. Or if this is Q, this is S. That's a conclusion. That's what is here. Yeah, any questions you can ask me? Okay. Yeah. Simply using the distance formula, children. I have nothing to explain here. If you have any questions with regard to working, please ask me. Yeah. Take down the question, start working. Simply using the distance. We are just using the distance formula and the property or the properties of the figure. Now here it's an equilateral triangle. So all sides are equal. Using that property, we'll be finding the values of x and y. Yeah, please work this. Right here, children. Any questions? Please ask me. Done this one, children? Yeah, okay. Done, children?
Yes, ma'am.
Yeah. So since you cannot solve it by splitting the middle term, we use the quadratic formula. I had already introduced the quadratic formula to you while explaining, some question earlier in, I think, prior to 2 classes. I remember, talking about the quadratic formula. So recall that or flip the pages in your notebook and see the formula. So solve for x using the quadratic formula. X is equal to 1 plus or minus root 3 by 2. And then you'll have to substitute that and find the corresponding values of y. Done, children? All right. So in this question, we are given the coordinates of two vertices of an equilateral triangle. See, the triangle is an equilateral triangle. That means all the three sides are equal. And we know two vertices, 3, 4 and -2, 3. So I have taken them to be A and B. Nothing is mentioned. So I have called the equilateral triangle ABC, and I've taken A as 3, 4 and B as -2, 3. Now, given this, we have to find the coordinates of the third vertex. So what is given to us? What kind of triangle? Equilateral triangle. And we have named it ABC. We know the address of two vertices, A and B. We need to find the address of C. So for that, you need to find the value of X and the value of Y. Very simple. Just use the properties of an equilateral triangle. So we know that in an equilateral triangle, all the three sides are equal. So from this, we get AB square is equal to BC square is equal to AC square. Now, instead of working, that means you can make three conditions here. See here. What is it? You have AB is equal to BC is equal to AC. When you square this, you get AB square is equal to BC square is equal to AC square. So from this, you can make three equations. AB square is equal to BC square. BC square is equal to AC square. And AB square is equal to AC square. Take any two. Just take any two. All right, so before we equate, AB square and BC square, we'll find what is AB square, what is BC square, what is AC square. We are given an equilateral triangle. Two coordinates are given to us. We need to find the third one. The third one is X, Y. And this is what we know about an equilateral triangle. All the three sides are equal. So that means AB square is equal to BC square is equal to AC square. Now let us find them separately. We are going to equate, but let's find separately what is AB square. X2 minus X1 the whole square plus Y2 minus Y1 the whole square. So we should use the coordinates of A and B and find AB square. Similarly, find BC square and AC square. Now that you have found this, we know that AB square is equal to BC square. AB square is equal to BC square. So this is AB square. This one is AB square is equal to BC square. Okay, so you get this equation. And then BC square is equal to AC square. When you equate that, BC square is equal to AC square, you get another equation. You get 5x plus y minus 6 is equal to 0. So now equation 1 and 2 can be solved by the substitution method. Because the first equation has x square and y square in it. The second equation has only x and y. So whenever you have a situation like this, you need to solve the equation. You need to solve for x and y using the substitution method. And how do you do that? So write x in terms of y or y in terms of x like this. So here y is equal to 6 minus 5x. 6 minus 5x. Now, how did we write y is equal to 6 minus 5x using this one? Using this 10x plus 2y minus 12 is equal to 0. Working this, we get y is equal to 6 minus 5x. Now substitute that in the first equation. We already have an equation, right? AB square is equal to BC square. We already have an equation here. So here, in place of y, use 6 minus 5x. In place of y, use 6 minus 5x. So see here, this is the equation. This is the equation 1. All right, wherever there is y, use 6 minus 5x. So there is y here and there's y here. Use 6 minus 5x. So when you work this, you get this equation, divide by 13 throughout, you get a simpler one, but you cannot split the middle term. So you use the quadratic formula and we find that the two values of x are 1 plus root 3 by 2 and 1 minus root 3 by 2. Now we found x, we got two values for x. We need to find the corresponding values of y. So substitute x is equal to 1 plus root 3 by 2 in equation 2. That means this one. In this one, in equation 2. Here you will have to substitute. Wherever there is x, use, see, this is the equation. In this one, we got two values for x. Now find the corresponding values of y. So here in place of x, use the first one, 1 plus root 3 by 2. You will get the corresponding value of y. Again, when you use 1 minus root 3 by 2, you will get the corresponding value of y. So like this, we found the coordinates of the third vertex, C. You can see here, C is given by this address or this address or this address. Yes, children. All the three sides are equal. So square it, you get AB square is equal to BC square is equal to AC square. Find them separately first. What is AB square? What is BC square? What is AC square? And then equate. AB square is equal to BC square. That you will get one equation. BC square is equal to AC square, another equation. Now you can solve these two equations only by the substitution method. Yeah. And then you get a quadratic equation which cannot be solved by splitting the middle term. So you use the quadratic formula. You get two values for x. And for substituting, you get two corresponding values for y. I don't know which one you're writing, children. You'll have to tell me. Anybody wants to finish this page? All right. Yeah, your questions, please. Done, children? Finish writing, children?
Yes, ma'am.
Yes. Okay, I'll wait for some time. Yeah. Please ask me your questions, children. All right. Similar question. Similar questions for practice. Please work. See, I hope you're all not blindly copying, children. It's just using distance formula and simplifying. I have nothing to explain here. If you don't understand some calculation, please ask me. And it's an equilateral triangle, so all sides are equal. So OA is equal to OB is equal to AB. When you square, you get OA square is equal to OB square is equal to AB square. So you can make three cases from this. OA square is equal to OB square. OA square is equal to OB square, and then OB square is equal to AB square. And before we do that, we find OA square, OB square, and AB square. The triangle is OAB. We find OA square, AB square, and OB square. Please work, children. Yeah, what's the corresponding value of y when x is 6 minus root 3 y by. Oh, okay, we have not still substituted. Okay, yeah. Who's completed this? Who's found the values of x and y? I'm not showing you the next slide. You have to complete this and tell me the values of x and y. Do the substitution method. I'm not showing you the next slide. Please work ahead and tell me the values of x and y. Yes, who's worked ahead? Priyanka, are you there?
Yes, ma'am.
I called out earlier. I didn't hear from you.
Internet issues, ma'am.
Okay. Kanishka, have you worked ahead?
No, ma'am.
who has gone ahead? Rajeshwari, where are you working? Why no response, Rajeshwari? Tarun Murali,
I'm working, ma'am.
have you gone beyond this page?
Ma'am, I got 6 minus, I'm writing 6 minus root 3 y by 3, 2 plus y square is equal to 12 now.
Okay, so you're there, is it? You'll have to continue from there.
Ah, yes, ma'am.
Okay, what about Kanishka? Netra?
Yes, ma'am.
Yeah, where are you working?
Yes, ma'am. And even
Okay, I'll wait for another 5 minutes because you must know how to solve this. Another 5 minutes, then I'll be forced to show you the answer. At least one of you try to finish it before that and share the correct answer with me. Yeah. Will somebody make me happy? Okay, so I'm not getting any responses. So I'm forced to show the answer. Anyone wants to share the equation you got? No response. Okay, so completed.
I did a calculation mistake.
Okay.
I forgot to multiply the denominator. Instead of 3 square 9, I wrote 3 instead. That's why I got.
Oh, the denominator, is it? Yeah. 3 square
Yes,
9,
ma'am.
so you wrote 3.
Yes, ma'am.
Okay. Good. Thanks for responding, Kanishka. Very good.
I will take care of this mistake.
So you identified your mistake. Now correct it. Very good.
Yes, ma'am.
Yeah. Done, children?
Yes, ma'am.
Okay, Kanishka has finished. What about the others?
Yes, ma'am.
Yes, ma'am.
Okay, Nandini, Tarun, and Kanishka have responded. Any questions, children? No? Okay. Yeah, take a screenshot of this one, children. Write the question. Leave some space. You can complete this later. So similar to the last two questions, equilateral triangle, two vertices given. You'll have to find the coordinate of the third vertex. Take a screenshot. Write the question. Leave some space. You can fill it later. Done, children?
Yes, ma'am.
Yeah. So this is the next one. So triangle. The circle passing through the three vertices of the triangle is called the circumcircle. Circumcircle. And we know that every circle has a center, and the center of the circumcircle is called the circumcenter. The center of the circle. The center of the circumcircle is called the circumcenter. What is a circumcircle? A circumcircle is a circle drawn passing through the three vertices of a triangle. Passing through the three vertices of a triangle. This is the circumcircle. The center of the circumcircle is called the circumcenter. And the radius is called the circumradius. Center to any point of the circumference. Circumradius. So circumcenter, circumcenter, circumradius, circumradius, and circumcircle. Circumcircle. So the question is, find the coordinates of the circumcenter. You should find the coordinates of circumcenter of the triangle with A, B, C known to us. Also find the circumradius. Also find the circumradius. So see the figure here. See the figure here. Can you see the triangle? ABC. I've marked the triangle ABC. ABC is a triangle. ABC is a triangle. I've marked the vertices. You can see A here, B here, and C here. And then I've drawn a circle passing through A, B, and C. So that's the circumcircle. And this is the circumcenter. Okay, I've marked this one as the circumcenter. This is the center of the circle, circumcenter. Now, when you connect the circumcenter to A, circumradius, circumcenter to B, circumradius, circumcenter to C, circumradius. Center to any point of the circle is a circumradius. Now, like in an equilateral triangle, all the three sides are equal. Here, we can see three circumradii, OA, OB, and OC. All the three are equal because they are the radius of the same circle. You can see here OA, center to any point of the circumference, OB, OC. All these are radii of the circle. The circumradii they are. So like in an equilateral triangle, all the three sides are equal. Here in the circumcircle, the circumradii, they're all equal. So OA is equal to OB is equal to OC, or OA square is equal to OB square plus OC square. Sorry, OA square is equal to OB square is equal to OC square. So equate any two to find the values of X and Y. Got this, children? OA circumradius, OB circumradius, OC circumradius. So OA is equal to OB is equal to OC. So you will get two equations. And you'll have to solve the two equations to find the values of X and Y. Are you all writing?
Yes, ma'am.
Yeah, thank you. Yeah. So I didn't say, this is all for your information, children. This is not a part of the answer. This is not a part of the answer. The answer starts here. The answer starts here. This is not a part of the answer. This is just for your information. Done this page, children? Shall I take you to the next page?
Yes, ma'am.
Yeah. So you can see we get two linear equations in X and Y. And on solving them, we're able to find the values of X and Y. That is the coordinates of the circumcenter. So next class, we'll take a test based on whatever you studied in this class. Based on whatever you studied in this class, we'll have a test in the next class. All right, children, if you have not completed, please take screenshots. Take a picture of the first page, this one. In case you have not finished. Yeah. So you can see after finding X and Y, we find the circumradius. You can find OA, OB, or OC for circumradius. I have found OB. Using the coordinates of O and B, I found the distance OB, which is the radius, the circumradius. Take a picture, children. Done? All right. All right, children. All right, children. So that's it for today's session. Thank you so much. Good night. Please complete whatever you are expected to.
Thank you, ma'am.
Thank you, children.
Thank you.
Good night. Thank you. Good night.